My assistant principal, Ms. Deason, brought it to my attention in regards to another school that she had been at before, had the robotics and program, and so I thought that would be something exciting for our students who participate in as well. In light of the fact that we, as a district, are moving towards more of STEM's programs, and so it was just a perfect opportunity for us to get on board and to get our students going with that process. I'm extremely grateful to Ms. Deason because she made all the contacts that need to be made in regards to making sure that our program was up and running, and the students are super excited about the program. They're learning so much, and the excitement every time I walk into the program is evident in their faces because they're always smiling. They're figuring out problems. They're working through the process of assembling the robots, and it's super motivating for them to be involved in the program. So I think part of the reason is because of the STEMs, and secondly, I felt like it would be beneficial for our students to get involved in the program.
Okay. And do you see what benefits do you see for the school or for the students in being a part of that?
Well, what I think the most important benefit is the fact that it focuses their attentions on science, technology, engineering, and math. And they're applying all those skills as they work through the robotics. And in addition to that, it kind of gives them an opportunity to say, hey, I think maybe one day I'll be a scientist or an engineer. Mm-hmm. And it gives them an opportunity to kind of practice that skill and figure out if that's something they feel like they want to do in the future, and if so, then realize what they need to do in terms of right now in terms of math and science to ensure that they are a proficient in that area.
Okay.
What part does the ball play? Just to make sounds? Pretty much make sounds? Are you coming back to see how you do it?
Instead of you say you wanted us to see how it moves, we got farther in it so that you can hear.
Oh, you guys have. So what have you done?
We built all of this, and we put the front of it, and we just it down, and we built the back of it just to make it even move.
Oh, nice. So how do you think, how did you guys come up with that idea to put a wheel on the back of it? How did that come about?
Like, we were looking in a book and we saw it, so we started doing it, and then we just attached it to the back of it, and it stayed there perfectly.
But how'd you guys figure out how all the parts work? Because there was a lot of different parts. That was like, how'd you put them all together?
Because Alex sat there by himself while we were doing something else, and he sat there and focused.
Oh, okay. Wow, that's pretty intense. So have you guys programmed it yet to move or anything?
Yeah, we programmed it just to move.
So how'd you figure out the programming? It seems like that's hard too.
Because in the book it shows us what to do.
It shows you the different programs. So is there certain buttons you have to push or something to make it?
Yeah, this is, it makes it come on. We use this to go left or right, and then this is when we press or break it.
Oh, so what do? You push it, you push the buttons, and you push it to program it so it can remember what to do?
Yeah.
Nice. Wow. That's impressive. I'm really a lot of math. Tell me about that.
Because like this, you have to measure the pieces to make it fit perfectly instead of like somebody picking up and redo everything.
Okay. So there's math involved too. What's another way you guys think you use math also? What's one thing? Science. Wow. So what do you guys think about the whole process?
I think it was a learning of like help us learn the process.
What do you think you learned the most about it?
I learned the most about it is like how we build it, because I didn't know how to build anything but the stuff that you just build by yourself. But this is different from how I used to do it, and now I learn how to build little pieces into big pieces like that.
Oh wow, yeah, it's kind of a tedious process. It takes a lot of patience and thinking. Right, in math, right? What do you think? What's been the hardest part for you? Most difficult part?
Trying to find the right size.
Oh, yes. Trying to find the right size. So how do you do that? Do you measure like Rhea said, or do you guys just kind of pick trial and error? Okay. So were you able to program it too? So how hard was that? Wasn't that hard? So what do you guys think about robotics?
I think it's fun.
Think it's fun? Really? What's fun about it? What do you think about it?
Because like we're learning how to build it, and we like some of our first time seeing us build a robot and seeing it build it.
What do you think you'll do with this in the future? Do you feel like it's something else you will continue doing, maybe in middle school or high school or in college, or what do you think?
I think it would help us like when our song about work.
In what way?
Like it'll like since we program it'll help us remember what we do with ourselves and then it'll probably remember what we learned the last time.
That's right. That's exactly right. Because that's all they do with computers. That's how they program it. It's just this own way. Good job, guys. I'm proud of you. You're trying to make a gorilla? Wow. That's impressive. So how did you guys decide to do that? I mean, I know you did the alligator.
Yeah.
So how did you decide to make the gorilla?
This one, the
Oh, so you guys figure out, the alligator only opens and closes its mouth, and so you guys, if you do the gorilla, it'd move its arms. Wow, that's So did you mainly look at the picture to assemble it? Yes. So how difficult do you think it's going to be to make it move? Like, you don't think it's going to be too difficult? You guys learn programming pretty quickly. Tell me about the sensor. What are the sensors?
She got lonely.
So you guys have to program
And come right back.
That's pretty impressive. So you guys have all people put together.
Go.
Where you got that?
It's not mine. I'm trying to get some out there and nowhere from. How long is the robotics class?
Till 4:30 today.
You guys say it's trial and error. Sometimes it works and sometimes you got to do something else. That's what you guys did and you figured it out. That's impressive. So did you program it or did you assemble it? You did both?
Assembled it while they program.
Oh, really? So you guys are the programmers and you guys are the... Whoa! Are you serious?
Yeah.
That's impressive. Wow.
We're going to try you
So, are you serious, guys? That's really good. How'd you figure that out?
Ramon, move back a little bit because I don't have your thing.
Okay, so you hook the wires up. What else? Wow. But you programmed it, so who assembled it? Who put it all together?
From the beginning, I started putting it together, and then so some other one came, and then he started programming them, and so then he gathered all the pieces, and then sometimes I started getting access, and then he built the rest.
Inventory specialist. Really? A mile high tower. That's interesting. I wonder how that works.
Obama and see what they're doing in middle school with their robotics program.
Oh, I like that idea. Do you guys like that? I can definitely make that happen.
I made sure that they went to school, have future aspirations to go to college for engineering and even as much as robotic engineering as I was. So I began a team out of Detroit, middle school team. I attended the school for career day. And while I was discussing what I did as a professional and how many vehicles for General Motors I was responsible for putting robots in the facility, I ended the the career day conversation with breaking out this Lego Mindstorm robot in front of the kids. They had never seen the robot ever before, and they didn't realize that I had just begun playing with it myself about a week before I went to visit them. However, coming out of the school, the principal asked me, said, would you like to come back and start your own Lego team? I said, well, that was definitely the goal here, and that's why I came with the robot that day. That year, that was 2006, we started our own Lego team. I had 20 kids. There were 2 different teams, and then we went on to compete in the U.S. First competition, and we got the Michigan Rookie of the Year award.
Wow. Congratulations.
The kids went on to the state championship. However, at that time I was on the road for General Motors, so I could not attend the state championship, and they didn't do as well. So I promised them I would never miss another competition, and I didn't. 3 years into the program, we had these 2 8th graders who had been on the team since we had began, and they were really determined to win. I told them after 3 years we should be a very good team. We'll know what we're doing, and we'll be able to move on and carry a legacy for the school of Burton International out of Detroit. That particular team, they went on to win 2nd place in the world at the RoboFest competition. They lost to a team from Korea. So that made them the state champions. They were the champions in the city, and not only that, but the champions in the United States. We went through several teams from different countries and different states throughout the U.S. So it was a pretty exciting time. We were just seconds away from winning the whole entire thing.
And didn't you tell me that the team that won was the girl team?
Well, that was it wasn't the girl team there. That was back in Detroit. So just recently, May 2010, I moved from Detroit down to Dallas, Texas, and my new company, Frito-Lay, they had a partnership with Zumwalt Middle School. I then said, hey, I got this program I do with kids, and it's a lot of fun. Would you guys mind sponsoring it? And they funded it, and we bought 6 robots, and I showed up at Zumwalt Middle School, and the kids had no idea what I was going to do. They thought I was just going to begin talking about my profession and just go over that week after week. We suddenly broke out the robots. They didn't realize that the Lego robots were going to move. So we built them up, and then on April 15th of 2011, we held a competition at Zumwalt Middle School. There were 6 teams. And the champions of that competition were these 3 young ladies who lacked some confidence when they began because they were up against all the boys. And they had help from some of the other engineers from Frito, as we all volunteered, myself and 4 other engineers from Frito-Lay, and we participated by helping them out. We had the NBC, CBS, and Fox all came out. The DISD joined in to take pictures, and it was a really big event for the whole entire city. And I think it kind of opened up the doors for the other DISD schools to get involved in robotics as well. So it's been an exciting year and a half for me since I moved from Detroit.
They're keeping you busy, right? Because I know
busy.
we've called on you, as I know you're also working with Barack Obama at school and everything.
Yes.
So what kind of do you see kids using math and science technology in building these robots?
Yes, the math is definitely there. Sometimes the kids have to determine how far they want the robot to go from point A to point B. And to do that, you have to determine how many rotations the wheels are going to take to get there. Depending on the size of the wheel, will determine how many rotations it'll take to get from point A to B. So sometimes I'll have the kids measure the wheel before they actually begin programming it. Just, let you tell me how many rotations it's going to take. Don't let the robot tell you. And there's a simple math equation to get it done, and they'll figure it out.
Yeah, it's amazing to me how quickly they pick it up.
Right.
And how quickly they
pick it up. There's a lot you can build into the Lego Mindstorm. I really applaud Lego for the technology that they've given. They've given something with high technology capability and broken it down to where a child can understand. I think that's super. There's several different sensors that some people wouldn't even imagine using until they were in corporate America. So to see, first through 12th graders using these tools at such a young age, I think it's a great thing.
Wonderful.
And the science gets applied in the robotics piece of it, and then the mechanical piece. So it's something for everyone to do. You don't have to be a really electrical person. If you know, and then you got people who are just good with their hands. They enjoy building. Then you have people who are really good on the computer. They don't do any building. They like to program. So there's a piece for everyone when it comes to engineering.
And that first group that you started with, have you been able to keep in touch with them? Yes,
I keep in touch with most of the kids from my very first team back in Detroit. In fact, I have 2 young kids who I'm very close to. We probably talk on the phone at least once a week.
Oh, wow.
They tell me how they're doing in school, their report cards. They're both determined to be engineers.
Oh, that's good.
One wants to be a robot engineer. He's kind of been my mentee since he was a 5th grader. He wrote a letter about me when I was the first year I met him. So it was pretty cool. And then some of the kids at the Zoom walk, I just saw one of the young girls who was on the team last year. She's now in high school. She isn't looking forward to being an engineer, but you know, it always feels good when you see them again and they say thank you.
Yeah,
so
that is
so
neat.
it's exciting.
It's neat. So you can see the direct influence of what you've done
Absolutely.
in their lives.
Well, you know, for me, I can't say I would be where I am with my career if it wasn't for a mentor who stuck in there and held my hand through some of those tough times and guided me initially in my career to help me along. So I think it's only right that I give back,
and that's good, because
thank you to him.
In all honesty, not many people do what you do. Not many people give back the way that you give back.
Yeah.
And Frito-Lay too, and allowing you to do that.
Yes,
so,
it's the only way to say thank you. You know, because there is no financial value for someone, you know, giving the gift of guidance, you know, to watch you succeed, you know, where it's not even about themselves, and this here isn't about me. You know, I want to, you know, build up future engineers.
Well, yeah, I think you've got some with us. So, is there anything else that you would like to say?
You know, I'm really excited about working with all the students here. It's been a blast. You know, like I said, I kind of went backwards through this whole process. I began working with high schoolers, then I began working with middle schoolers. So to be working with elementary grade students was something I scratched my head on, because I've done career day with first graders and didn't even know how to communicate well enough to make sure that they understood me. Instead of talking about cars, I had to discuss transformers just to get them on the same page. But I'm glad to say that these kids here at BH Macon have really taken a hold of things, and even without my guidance around, they definitely looked over the instructions. They understand what's going on, and they're excited about it. So I appreciate you guys letting me be part of that.
We appreciate you. Thank you for doing it and telling us, getting us started and all, because we wouldn't know where to begin without you.
This is just the beginning. The best is yet to come.
Oh, really? What's to come?
Well, what's next is there'll be more engaged and exposed to different robotic competitions, knowing that they have options in the future. More importantly, it lets them know that they can do it.
I know that's very
there's
important,
nothing holding them back but themselves. You know, and I wouldn't want anything to stand in their way. I'm really glad, you know, even without me not being able to be around every week, that they kept on going. They could have easily given up, but you know, I'm glad to be here today. That they seem excited. All the robots are complete, and we'll be having a competition right here real soon.
Well, thank you.
You got yours pointed downward already?
You need something. You need something. Okay, we have a piece over here. We have this piece.
I hit it. Alright, so it says cannot find the device. So we know it's plugged all the way in. The motors, C and B, are where we have the motors hooked up to in here, okay? So, looks like the arm is on A, so that means the other two are on B and C. Okay, and then the light has 2. So, we want to make sure that this one here is talking to number 2. I'm going to put my wires untangle it a little. Okay. Do is stay on this board, and it should not be able to get past this white line. So we might have to adjust some of the parameters. But let's see what happens. I'll let you hit the button. Go ahead. It's gonna wait 5 seconds, and then it's gonna take off. Tangled up. Hold on a second, guys. We can try to download somebody else's robot if you guys got a set. We got to get these wires untangled for you guys.
Oh, look at it.
Uh-oh. A little heavy on one side. Alright, we're going to have to fix that when we come back next time.
Yeah, we'll fix it. All right.
What I'd like to do when I grow up is a robot builder. We use math when we look at the pieces. We count how many holes does each piece has, and we compare it to the pieces on the page. My favorite thing about robotics is we get to build and learn stuff I haven't learned in the past.
Like what? Can you tell me something you've learned?
I have learned when a robot closes its mouth and opens it, or flaps its wings, or moves, or any kind of other stuff.
Okay. And you were telling me earlier, talking to me about sensors. What is a sensor?
A sensor is a kind of motor that makes other pieces move, or they could just stand there while they're making other pieces move.
Do you have anything else you want to say?
I like being on robotics. This is my first year on robotics. I like it so much. I wish next year I will be on robotics again.